Trigonometric substitution is a technique which handles three types of expressions. So there are three types of trigonometric substitution, which are these. The secret behind these expressions is the first one. We have a square minus x square. A is a number actually. It looks like 1 minus sine square, which is equal to cosine square. And the second one, it looks like 1 plus tan square, which is equal to secant square. And the last one looks like secant square minus 1, which is tan square. This is the secret behind this expression, and this is how to remember which one to use. And that's why for the following discussion, we're going to use these three identities. 1 minus sine square theta equal to cosine square theta, and 1 plus tan square theta is equal secant square theta, and secant square theta minus 1 is equal tan square theta. Now, substitution 1, which is this one. A square minus x square, which we said it looks like 1 minus sine square. This is how to remember the substitution. So we are going to take x equal a sine theta. You see, it looks like 1 minus sine square, so we're going to take x as sine theta, a sine theta actually. What is a? A is square root of this number. Because if we do this, then the root will be simplified as follows. The root will become a square minus a square sine square, which is x square, a square common factor outside as a, so under the root we are going to have 1 minus sine square, which is cosine square. Root of cosine square is cosine. Which means if we take this substitution, the root will become a cosine theta, which is very easy to integrate. This can be seen nicely using an example. So let us look at this example. Now, this is 1 over root of 1 minus x square, so it looks like a square minus x square. This integration is very simple. It is calculus 1 stuff. We know this integration is sine inverse x. But let us try trigonometric substitution. We know what should be the final answer. Now, we are going to take x equal a sine theta, like we said here, because it looks like 1 minus sine square. So we'll take x equal a sine theta. A square is 1, so a is 1, so that will be sine theta. So root of 1 minus x square will become 1 minus sine square, because x is sine theta, and this is equal to root of cosine square, which is equal to cosine. So this root will become cosine theta. But since we have changed x into theta here under the root, we must change also dx. From x, dx is equal to cosine theta d theta. So the integration will become equal to 1 divide the root is equal to this, which is cosine theta, and dx is equal to this, which is cosine theta d theta. So we have integration of 1 d theta, which is equal to theta plus c. Now we have to replace theta by x using the first substitution. Now x equals sine theta, so theta is equal sine inverse x plus constant. Now, before we see the second type of a trigonometric substitution, let us see another example for the first type, which is this one. This is now a square minus x square, which we said it looks like 1 minus sine square. So we are going to take x as a, which is square root of this, 2 sine theta. So now here the power is not only a square root, it is a cube of a square root. But anyway, we will concentrate, let us concentrate on the expression, which is a square minus x square. It is important as the power. Maybe it is even more important than the power. 4 minus x square is equal to 4 minus 4 sine square. Then we'll come back to the power, which is a square root or whatever. 4 1 minus sine square theta is equal to 4 cosine square theta. This is 4 minus x squared. Now, dx is equal to 2 cosine theta d theta. So now we are ready to substitute in the integration. We are going to leave the limits, which are the values of x, until the end of the integration. So let us do the indefinite integration. Dx is equal to cosine theta d theta, and 4 minus x squared is equal to 4 cosine square theta to the power 3 by 2, which means this is equal to 2 cosine theta d theta divided by, we have square root, so it is 2 cosine theta to the power 3. So this is equal to 2 divide 8. 8 is the cube root of 2, and 1 cosine cancel with 1 cosine here. We are going to have 1 over cosine square theta d theta, which is equal to quarter 1 over cosine square secant square theta d theta. So the integration is 4th tan theta. Now we have to replace theta by, we have to write the answer in terms of x using the first substitution. Now how do we do this here? See, we have a ratio here which is sine theta is equal to x by 2, which means we can find other ratios, tan theta or cosine theta, from the triangle, because sine is opposite by hypotenuse. So this is x, this is 2. And we can find the third side, which is equal to root of 4 minus x squared. Now, so this can be written as 4th tan theta, and tan is opposite by adjacent, so it is equal to x divided 4 minus x squared. So the integration from 0 to 1 for dx divide 4 minus x squared, this is the original question. We are going to do the limits now, is equal to x divide 4 root of 4 minus x squared from 0 to 1. Now if we substitute x by 1, then minus by x by 0, then we are going to have 1 divide 4 root 3 minus 0, which is equal to 1 divide 4 root 3. The second type of trigonometric substitution is a squared plus x squared, which looks like, as we said, 1 plus tan squared. So we are going to take x as a tan theta, because if we do this, then square root of a squared plus x squared, it will become a squared plus a squared tan squared theta for x squared. A squared is common factor, it will come outside as a, under the root 1 plus tan squared, which is secant squared, root of secant squared as secant theta. Which means if we have the root of a squared plus x squared, and we take x as a tan theta, then the root will become a secant theta. Let us see this in this very simple example. Now we know from calculus 1, this is actually equal to tan inverse x, integration of 1 divided 1. But it is the second type of a trigonometric substitution. It is 1 plus x squared to the power of 1. So you see, the power is not very important as long as we have the expression, which is a squared plus x squared. Now, let us see. So we are going to take x equal a. Now a squared is 1, so a is 1 tan theta, because this looks like 1 plus tan squared. Then 1 plus x squared, it will be equal to 1 plus tan squared, because x is tan, which is equal to secant square theta. Dx, which we have to replace it also, is equal derivative of tan is secant square theta d theta. So the integration will be equal to 1 divide 1 plus x squared as secant square, and dx is also secant square, and we are going to have integration of 1 d theta, which is equal to theta plus c. And theta from the first substitution is equal to tan inverse x. Now this is another example for the second type of a trigonometric substitution. This looks like 1 plus tan square as we said before. So we are going to use tan for the substitution. But here we have 9x square instead of x square. When we had x square, we write here x equal a tan theta. Since we have 9x square, we are going to take 3x, which is square root of this. So 3x is equal a tan theta. A square is 1, so a is equal to 1 also. So it is a tan theta. Then the remaining is just like before. So we are going to calculate now the root, this root of 1 plus 9x square, which is equal to the root of 1 plus 9x square is square root of this, so it is square tan square, which is square of that. So this is equal to secant square theta, which is equal to secant theta. And x is equal third tan theta, so dx is equal third secant square theta d theta. Now we can say integration is 3 divide the root, which is this secant theta, times dx, which is third secant square theta d theta. This is equal, cancel this with this, so we have integration of secant theta d theta. If we cancel secant with secant here, integration of this is ln secant theta plus tan theta. This is equal ln, and we have to replace now theta by function of x using the triangle. From this ratio, tan theta is opposite by adjacent, so this is 3x divide 1. This is opposite, this is adjacent, so this is 1 plus 9x square. Secant theta is reciprocal of cosine, so this is going to be 1 plus 9x square plus tan theta, which is already this is equal to 3x. Now, this is the third type of a trigonometric substitution, which looks like secant square minus 1. This looks like secant square minus 1. And that's why we are going to take x equal to a secant theta. And if we do this, the root x square minus a square, it will become a square secant square, which is x square, minus a square, which is this. If we take a square common factor, it will come outside the root as a, and under the root we are going to have secant square theta minus 1, which is tan square, and root of tan square is tan, so we are going to end up with a tan theta, which means if we have x square minus a square, and if we let x equal a secant theta, then the square root of x square minus a square, it will become a tan theta. Let us try this example. Now, here, this looks like secant square minus 1. So we are going to take y equal a, which is 5 secant theta. So the root of y square minus 25, y square will be 25 secant square theta minus 25, which is equal to 25 common factor outside the root as 5, and this is secant square theta minus 1, which is equal to 5. Secant square theta minus 1 is tan square, and root of tan square is equal tan. So the root is equal to a, tan theta, like we said here. dy is equal 5 secant theta tan theta d theta. Now we are ready to substitute in the integration. So we have integration of the root, which is 5 tan theta divided by y cube, which is 125 secant cube theta, times dy, which is 5 secant theta tan theta d theta. Now, this is equal to 25 divided 125. That will take care of these. 1 secant is cancelled here, so we have integration of tan square theta divide secant square theta, which can be done either by saying tan square equals sine square over cosine square and secant square is 1 over cosine square, or it can also be done, this can be written actually as 1 divided 5 now, and this can be done by saying secant square theta minus 1 divide secant square theta d theta, which can be written as, you can separate numerator, secant square divided secant square is 1, and then minus 1 divided secant square, which is cosine square theta. 1 minus cosine square is equal to sine square, and sine square can be integrated by writing 1 minus cosine 2 theta divided 2 d theta, which can be written 1 over 10. Integration of 1 is theta, and integration of cosine 2 theta is 1 divided 2 sine 2 theta. Now we are going to use the triangle to replace theta by x. Now, but we have to write this in terms of theta. So this will be written as 1 divided 10 theta minus half times 2 sine 2 theta is sine 2 sine theta cosine theta plus c. 2 cancel with 2. Now we are ready to use the first substitution to replace the final answer with x. This is theta. We have secant theta equal y divided 5, so cosine theta is 5 divided y. So this is y square minus 25. So this answer can be written as 1 divided 10 theta from the first substitution, from this substitution, is secant inverse y divided 5 minus, which is this, sine theta opposite by hypotenuse, cosine theta adjacent by hypotenuse plus constant. Now this is one more example for the third type of a trigonometric substitution. This is exercise 31. As you can see here, we don't have a square root, but we still have the expression, which is x squared minus a minus 1 minus a squared. Well, that's the main thing really. So we are going to take x equal to a, which is 1 secant theta. So x squared minus 1 is equal secant square theta minus 1, which is equal to tan square theta, and dx is equal secant theta tan theta d theta. So the integration becomes x cubed, which is a cube of this, so it is secant cube theta secant cube theta. Let us rewrite this again. divide by x squared minus 1, which is tan squared theta, dx, which is secant theta tan theta d theta. This is equal to, we can cancel one tan with here, so it's equal to secant 4 theta d theta times tan to the power minus 1 theta. Since we have an even power of secant, so we can save a secant square theta out. We have tan here to the power minus 1 theta, and we have secant square theta, which can be changed into tan, so we have u and u prime. So this is equal to tan inverse, sorry, not inverse, tan to the power minus 1 theta times 1 plus tan square, this is for secant square, and this secant square is saved as du. So the integration will become integration of tan to the power minus 1 theta plus tan to the power minus 1 times tan square. So we add the powers, it will become tan theta times secant square theta. So this is u and du now, because if we take u as tan theta, du will be secant square theta d theta. So the integration becomes u to the power minus 1 plus u du. Integration is ln u plus u square divided by 2 plus constant. Now we replace u by tan theta plus u square, which is tan square theta, divided by 2 plus c. Now, from this substitution, we can draw the triangle for theta. Secant theta is x, which is hypotenuse by adjacent, so this is x squared minus 1. So this will be equal to ln tan theta, which is opposite by adjacent, plus tan square, which is x squared minus 1. Tan is again opposite by adjacent, so it is x squared minus 1 divided by 2 plus constant, which can be written as ln x squared minus 1 plus x squared divided 2 minus half plus c, it will become c. Now one more example for section 8.3, trigonometric substitution. Let us see number 35, which is slightly different than the previous one or the previous exercises we did in this section. We have here, we don't have x squared, we have e to the power 2t. But e to the power 2t actually is a square of e to the power t. So let us do some change of variables here. We can take x equal e to the power t. So we're going to have integration of x for e to the power t here, and root of, this is square of e to the power t, so it's x squared plus 9, and dt here can be calculated from here. T is ln x, so dt is 1 over x dx. Then we can also change the limits. These are the values of t, so we can say for t equal to 0, x is equal e to the power 0 from here, which is 1, and for t equal to ln 4, x is equal e to the power ln 4, which is equal to 4. So from 1 to 4, the values of x, and we can write also dt, which is 1 over x dx. So the new integration now is 1 to 4. This cancel with this. So we have changed the variables and we have made the integration looks like it is more simple than the first one. So we are going to start actually from here now. This is the same integration but in terms of x. Now this can be done using a trigonometric substitution, and this looks like tan squared plus 1. So we are going to take x equal 3 tan theta. So the square root x squared plus 9 will be, as we know now, 3 secant theta. And dx is equal 3 secant squared theta d theta. Let us do the integration without the limits. We are going to replace x at the end. So this will be 1 divide a 3 secant theta, and dx is a 3 secant squared theta d theta. This is equal integration of secant theta d theta, which is ln secant theta plus tan theta. Now, this can be written now in terms of x using the triangle. If we use this now, substitution, we can draw the triangle for theta. Tan theta is x divided by 3 from here. So this is equal to 9 plus x squared. We can now find this and write this as ln secant theta is root of 9 plus x squared divided by 3, and tan theta is x by 3. So the definite integration now 1 to 4 for 1 divide x squared plus 9 dx is equal to ln 9 plus x squared. We are going to write this again and use the limits now, plus x divided 3 from 1 to 4. We can replace 4 and then replace 1. If we replace 4, we are going to have a root of 25, which is 5 divided 3 plus 4 divided 3, and then replace 1, so it will be ln root 10 divided by 3 plus 1 divided by 3, which can be calculated using the calculator.